All right, this is the video lesson for 9A.1. Module 9 is kind of long, so we've split it into two. A is going to focus on exponents and B is going to focus on radicals. So today, as you can see here, we're going to look at the exponent rule for 0 and also for negative exponents as well. So very easy for the 0 exponent. Any number that's to the power of 0 is just 1. And all these questions here, you could actually check easily on Desmos if necessary, if you're not sure. 0 to the 0 is undefined. That's something for a much later class, so we're going to move straight on to the next section. So for all these, make a prediction. This one I see isn't to the power of 0, so I know this is 1. Same here, same here, same here. So all these numbers, as I can see they're to the power of 0, then I know that the answer is just going to be 1. Now, as we start applying that to questions then, as we know that x to the 0 is 1, and I can see that it's next to a 9, that means that I'm doing 9 times 1, which would just be 9. As I do the same thing here, I see the 0 exponent, which I know is 1. 3 times 1 would just be 3, and then it would just be b to the 5. So essentially, it's almost like the x to the 0 almost cancels out. With it being 1, when you times by 1, that doesn't do anything. So it's almost like you can cross it out. Check answer there. There we go. And on the last one, I can see this whole thing is to the power of 0. So I know all this is 1. 8 times 1 would be 8. So in other words, it's really just the first set of parentheses. So pretty easy rule to use. It's basically making sure that you don't put 0 as the answer. I know that's a problem that some people have when they forget or they get careless. As we're moving on, we're now starting to move on to questions with division. So for division, that's where we subtract the exponents. So 2 take away 0 is 2. And 6 take away 3 is 3. So no real difference. We subtracted, it just happened that one of the numbers was 0. Something big here, but to the power of 0, so that would also be 1. We could just type that one in straight away. And looks confusing, but we'll just work out each term individually. So something to the power of 0 is 1. Something to the power of 0 is also 1. So 1 plus 1 would give us 2. And that should be good as well. Then there's a little exercise to practice on putting things together. Do they equal 1 or do they equal negative 1? Now, some of these are very close to each other, like this one and this one here. They look very similar indeed. Now, if you're not sure, remember, you can go to Desmos like we talked about. Now, the one inside the parentheses, this number to the 0 is going to be 1. This to the power of 0 is going to be 1. And this to the power of 0 is going to be 1. Now, I'm actually not going to join them together or else you can't see them very well. And these ones would turn out to be negative 1. So let's look at these two in particular so we can see the difference. The difference for this one is I'm doing a number to the power of 0. This one, I'm doing my order of operations. I'm doing 8 to the power of 0, and then I'm doing the negative of it. So any term that has a negative at the start, basically what I'm doing is this is 1, therefore the answer is negative 1. So notice if the negative is at the start of the question, it equals negative 1. If the negative is inside of parentheses, then that's fine. That doesn't change the answer. That means these would all be 1. If I just go ahead and join them all together now, then on the next slide, whoops, we can actually just check just to make sure that that is correct. And I think I missed one down here somewhere, so it's probably going to say I got most of them correct. I got 8 out of 9. There's one that just got, oh, there it is. Just got hit, and now I got them all correct. So that's the first part done, and now we're on to negative exponents. So with negative exponents, there is a little pattern we can do here. 2 to the power of 2 is 4, because obviously it's 2 times 2. That's not a real problem. 2 times 1 just means we have 1, 2, so the answer is 2. The reason this gets confusing is how do you write 0 2's down? And how on earth does that give you an answer of 1? We know to the power of 0 is 1. And admittedly, that is kind of tough. Now, if we follow the pattern here, notice it's halving each time, or we're dividing by 2. So this answer here, if we continue that pattern, would be 1 over 2. And this would be 1 over 4. So notice things with negative exponents, as in these two terms here. The answer is not actually negative. It's actually just a fraction. And the fraction that it generates is 1 over 2 to the power of 1. 2 to the power of 1 is obviously 2. That's why we have 1 over 2. 2 to the negative 2 is actually 1 over 2 squared. and 2 squared is 4, so the answer would just be 1 over 4. And that's basically all we're going to do. Negative exponents in the numerator get moved to the denominator and become positive exponents. So here we have a negative exponent, move it to the bottom of the fraction, and it becomes positive. Same thing, negative exponent, move it to the bottom of the fraction, and we get a positive exponent. So questions like we just saw, we just switch the position. So the negative exponent doesn't mean it's negative. It means that the exponent switches positions and becomes positive. Now, if we have nothing on the top of the fraction here, then we always put a 1 here. Like if there was a number at the start here, say 9, then I would put 9 over x to the power of 4. Remember, technically, this is 1x to the negative 4. That's the other reason why the 1 stays at the top. But the thing with a negative exponent moves to the bottom. If we have a question where we have to work something out, sure, I can actually bring this to the bottom of the fraction and put 3 to the 5 divided by 3 to the 8. Subtract exponents, 5 take away 8 is negative 3. Or I could just go ahead and add these just together straight away. We know we're multiplying, negative 8 add 5 is negative 3. And then that same thing, anything with a negative exponent, we're going to bring to the bottom and we're going to make it positive. Now that rule works in reverse as well. If we have a negative exponent on the denominator, we're going to move it to the top of the fraction. Now you might be saying, whoa, where did this 1 disappear to? Well, actually it didn't disappear anywhere. It became 1x cubed, which is just x cubed. 6 to the negative 2, move it up as 6 squared. And same thing, 1 times 6 squared is just 6 squared. So it just looks like the 1 actually disappeared. Quick question, you might want to pause the video and have a try on this question. The answer for the correct one is certainly this one here. So 2 to the negative 3 means 1 over 2 to the power of 3. And 2 to the power of 3 is 8. So this would be the correct answer. They made the mistake of thinking a negative exponent means the answer is negative, which is not true. It means that it's a fraction and it moves to the bottom. Now you can have ones with 2 terms. If you have that, then you just apply both rules. The term on the top moves to the bottom. Technically, it would be 5 to the 1 here, but 5 to the 1 is just 5. And a to the negative 2 moves up to the top and becomes a to the positive 2. All right, and we can start having a practice on what these questions actually are. So how would we rewrite this expression so it doesn't contain a negative exponent? So we change its position. We make it positive, but we move it to the bottom of the fraction. And remember, this is technically 1x to the negative 8. Therefore, we put 1 over x to the 8. So that negative, it basically makes it a question of fraction. For this one, it's on the reverse. This is actually on the bottom here. So I'm just going to move it to the top. Once I move it to the top, I don't have anything left on the bottom of the fraction. So I'm not going to draw my fraction here. And as it's 1x to the 4, I'm just going to put x to the power of 4 and leave it like that. 4x to the negative 2 is often one that people do get wrong. The thing that has the exponent is the x, not the 4. So the 4 just stays where it is. But the thing with the negative exponent has to switch positions. So instead of being on the top of the fraction, it moves to the bottom of the fraction, and we change the exponent. We have an exponent on the bottom, so this one is going to move up and become positive. So 5x to the 8, oops, that looks more like a 9. Let me try and make that a little bit clearer. There we go. And you're not done on this one either. Don't forget your basic rules. There is a fraction here that clearly simplifies. This would be 1 over 2. So you could put 1 over 2 x to the 8. Or you could actually just put x to the 8 over 2. You don't technically need the 1 there for this either. Now, ones like this one we're multiplying, this is the same as the units we've done actually a couple of times. You're going to multiply numbers first, letters second, and do it probably in alphabetical order most of the time, or normally in the order that you see the question. So 3 times negative 5 is negative 15. X to the negative 8 times by x to the 8, add the exponents together, would give you x to the 0. And there's only one term with an r in, so that would be r to the 7. As x to the 0 is 1, negative 15 times 1 would just be negative 15, and r to the 7. So once again, it's almost like this x to the 0 just cancels, and we just get left with whatever other terms are left. Getting a little more complicated. Same thing though, numbers first. 1/3 times 6. If you're not sure, just use Desmos. Really, this is 6 divided by 3 is what I'm doing here. For the m's, add the exponents together. Negative 5 add 8 is 3. And for the r's, 7 add negative 9 is negative 2. And our question says leave no exponents, negative exponents. So anything that's negative is just going to switch. So this r to the -2 would just move to the bottom and become r squared. No numbers to simplify here on this one, so this is just 9. -8 take away 5 is -13. And then that same thing. We're not allowed to leave any negative exponents in our answer, so it's going to move to the bottom, and it's going to become positive. No numbers, just letters this time. So 7 and take away -5 is 12. And I'm going to do 2 stages at once here. -13 take away 3 is -16. So I'm not going to write it straight away as -16. I'm just going to put it as 16 on the bottom. That's what the negative exponent actually means. Bit of everything on this question, numbers and 3 letters. 14 divided by 7 is 2. X to the 5 divided by x to the 3 is going to be x to the 2 because we're subtracting exponents. -3 take away -7. Please use your calculator for these. A lot of people were guessing, saying things like -10, +10. It's actually +4 for this question, so just be careful. And 3 take away 8 is -5. So much like the last one, I'm just going to write the answer on the bottom rather than on the top. And one last question from the VDOE. And so we're multiplying here, so we know we're adding the exponents. So p add -9 equals 3. If you've forgotten how to solve an equation, remember you can actually use Desmos for this. So you could just pull up a Desmos calculator, type in the question, look for the vertical line, and it's where it goes through on the x-axis, and it's actually at 12. 12 add -9 is the same as 12 take away 9, which is definitely 3 for this question. And we can see that that's good. Power to a power rule, well, we covered it, but very briefly. So what we do is we actually multiply these 2 powers together here. So I would have -2 times p, which is -2p. And this here, as this is on the bottom of the fraction, that means originally it must have been up on the top and it was negative. So this is actually x to the power of -8 here. And then you could set -2p equal to -8 and solve. And I believe that gives you 4. And for the last one, I see that it equals 1. And I remember from earlier, anything to the power of 0 would give us 1. So a few key rules there. Go back and look at them. Anything to the power of 0 is 1. Anything with a negative exponent is going to switch positions and become positive. So if it's on the top, move it to the bottom and then make it positive. Or if it's on the bottom, move it up to the top and make it positive. And that's it for this video. Go ahead and practice using the exercise that's been assigned.